Are we live? All right. So this is William Chen, aka Will the Shill. Chen, developer relations at Terra, and today I'm going to be presenting about some new contract tools that are currently in the works and that will kind of automate the boring parts that you might encounter in the process of building great dApps. Like all great dApps on Terra have a couple things beyond the smart contracts like a web app, documentation, CLI, and these contract tools are there to help automate the tedious parts that often come up and serve as like a source of friction for developers. So the first use case of contract tools is automated documentation. Now, documentation is one of the most important parts of a project. That's how new developers come in and figure out, how does this project work? How can I get involved? How can I create apps that build on top? And so documentation really leaves a lasting impression because it's usually the first place users and especially developers go to learn about your project. The problem with documentation is we often are developing so rapidly that it's hard to keep it in sync, and it's hard to figure out a format because no projects have kind of given a format that most projects can follow. But now we're going to change that with automated documentation. So with automated documentation, what do we get? First of all, we get a single source of truth because documentation for the contracts can be derived from the source code and then always reflect the latest changes. So the documentation is always kept in sync despite being under constant development. Secondly, with automated documentation, you get a consistent format. So because we can use templates to generate documentation, we can be sure that there's little room for human error, and we can ensure a consistent formatting throughout the documentation, giving the sense of a unified experience. And finally, we can make it beautiful because we can put that outputted Markdown into a theme of your choice. And Markdown is a versatile format so that you can easily style it to match the design language of your project. So for an example, I'm going to go over a little bit of the Nebula documentation. This is a sneak preview. The Nebula documentation is automatically generated through these contract tools. As you can see, the message interfaces, instantiate message, execute message, and query message are all automatically generated, pulled from the source code. Because it follows a consistent format, because COSM-WASM contracts all follow this similar pattern of interacting with JSON, you can be sure that, we can utilize this this predictable pattern to automatically generate the documentation for the contract interfaces. Second, we have tools. We are generating tools that allow you to build SDKs. So what is an SDK for in terms of a smart contract, and why is it important? Now, an SDK is not necessary to interact with your smart contract, your project, but without an SDK, developers would have to drop down to a lower level of interaction, which is directly building messages and formatting those messages and making the transactions in the right way by themselves, which can lead to a lot of human error. And it's frankly not a very good experience for the developer. So if you provide an SDK, you can ensure that more developers it can access your product more easily. And this allows the developers to be happy and have a good experience while playing around with your protocol. And that ultimately factors in a lot with the decision on whether or not a developer decides to build something on top of your protocol or work with you in the future. So we understand that building SDKs have very similar a feel for building, like compared to building documentation. If you think about it, documentation and SDK are kind of very similar because they can be derived from the same structure. The SDKs, in the sense of creating those messages that your smart contracts can accept, those you can use the same information used to derive the documentation to build SDKs through a code generation process. So we are going to be releasing an SDK generation tool. It will work with both JavaScript and Python, so you can generate SDKs that work with either Terra JS or Terra SDK for Python. And future, in the future, when we have other language SDKs, we will also support those. SDKs will allow you to easily expand your reach by providing developers an easy way to integrate with your project. And finally, if you generate the SDK, you have something to start with. So you might not ultimately use the generated SDK as is, but it will be an easy way to provide the scaffolding, provide a solid structure, provide a framework that you can use to add more custom parts. So the tedious parts we can take care of with automation, and the more custom logic, you can focus on building some custom logic or business logic. And it's always easier to have something to start with rather than starting from nothing. So as you can see, the SDKs, such as the Mirror SDK, all follow a similar format. The Mirror SDK is used to, create messages so that you don't need to necessarily understand how to properly format a message. And it can do some prior verification so you don't get a nasty contract error. Okay. Third, let's talk about CLIs. So we can generate CLIs with the same information used to generate the SDK and documentation. As you can see, you can easily go, like Mirror, for example, is just a collection of smart contracts, and each smart contract has a format. And if you point the, basically, it's just another step from the SDK to a CLI, if you think about it. Once you generate the SDK, all those functions generated by the SDK can just be put into a CLI, where the CLI would just input values from the user collected from the terminal into the SDK function calls. And then if you configure it properly, such as the, for example, Mirror contract addresses, then those functions will be able to execute against the real values on the blockchain. So this is just another cool thing. You don't necessarily need to provide an CLI with your product, but it's nice to have, right? You don't necessarily want people to be dependent on your web interface because sometimes it might go down, and you might also want to appeal to power users who are more comfortable like writing scripts with the CLI. Okay, so finally, another use case is a web user interface generator. So the most difficult part about creating a web interface, about creating a dApp, is creating the web interface. So this tool generates web forms, so you have something to start with, and it reads the message formats defined by the input schema to automatically generate these forms. So I'll show you a demo later with the Nebula ones. But yeah, so how does this all work? And to show you this, we're going to just be doing, we're just going to be building your own contract tools, a simple one. And sorry, I'll just, so I'll be building a simple contract tool just to show you how you can build your own and how you can use these contract tools in the future. All right, so the first step is you need to generate a JSON schema from the smart contract source code. The second step is you're going to parse the generated JSON schema to create a tree representation. And we're going to walk the tree structure and apply some custom logic. So I'm just going to go ahead and go to a demo now. All right. Okay, so let me load up VS Code. So I've, is this screen, is this large enough? Okay. All right, so this is my TS config. I'm going to be using TypeScript. So I created a, okay, so yeah, this is the, this is the demo from earlier. As you can see, you can go into each of these, contracts, and within each of the contracts, you have, different types of messages you can execute, instantiate message, for example. And then at the end, you have, it creates a JSON message that you can do. And you can also, it also verifies the JSON. So for example, if you don't know which value it's supposed to be, right? Like if it's supposed to be a number or a number as a string, then this will automatically do it for you. And also you can go into the different types of messages, like, so let's say incentives and execute, and you can go to like, create, and we can add another item. So this automatically generates a UI if you pass in the schema that's generated. So now I'll go back to VS Code and I'll show you how you can build your own. So let's see. Let's go to npm first, and I'll show you the package I'll use. So it's called parse cosmosm schema. Right. So parse cosmosm schema takes in a JSON schema generated by cosmosm and creates a smart contract tool, or creates a tree that you can use to build a smart contract tool. So this kind of shows you how the tree structure and how you can walk the tree structure, the types of nodes that you can see. And we will be shipping a couple contract tools. And, these are the ones provided by Terraform Labs, but in the future, you can build your own tools that if you don't find the ones that we provide sufficient, or you can fork one of our tools and you can contribute by adding your own. So be the first one to contribute a community tool by creating one. All right, so let's get started with showing you how. So this, I set up basically TypeScript. So what I'm going to do is just, make sure that TypeScript just runs. So I'm just going to build a simple tool for, let's say, outputting to the console the various variants of an execute message. So let's call this print execute message. Okay, so all right. So what we're going to do is we have to get a JSON schema first. So what I'm going to do is, let's just use the one from TerraSwap. So I'm going to go to TerraSwap. And let's see, do we have the schemas here? We do not. Okay, so let's get TerraSwap locally. And I'm just going to put in the same one. I'm just going to put in the same directory, clone that TerraSwap. So now I have a local version of TerraSwap. So I'm just going to go into my Terra swap and see. So let's do something for the factory contract. Oh, actually, it does have a schema. All right. So let's build a. Let's see. Is this seems a little bit too simple? Let's go with a more complicated JSON schema. Okay, this looks sufficiently interesting. So, all right. So now this is the JSON schema that is produced, but how does this JSON schema get built? So, we go into contracts and we go into the router. And if we go into the router, we see that there's some code here called schema.rs under the examples. And CosmWasm, if you use the CosmWasm template, they have provided like a script called schema. So you can just run cargo schema, and it should build that JSON schema for you if you don't have it. Okay. Hold on, my mouth is getting a little bit dry, so I'm just going to get some water. Be sure to remain hydrated if you're working on CosmWasm. Okay, so now we have the schema in execute message. So what I'm just going to do is I'm going to take this schema and just paste that in. So paste in JSON. All right, let's just hide this. Okay, so now I have the schema. So the first thing I'm going to do is just, see if this prints to the screen. So I'm just going to stringify this schema, prettify it. Just make sure that it all works. Okay, and then run the print execute message. Okay. So the first thing you want to do is you're going to want to import the parse schema function from parse CosmWasm schema. So I'm just going to import parse schema from parse CosmWasm schema. So you're going to want to yarn add this or install this according to the npm instructions. Okay. So the first thing is let's create a print execute message. Execute message. So it's going to be asynchronous because parse schema is asynchronous. So schema, let's define this as any, and we have to do a promise, any for now. Okay. So first of all, what happens when we okay, so let's just print execute message schema. So what happens when we just parse schema, right? So we're just gonna wait this and parse schema. Let's see what is the output, right? So tree, the output is a tree. So if we type in that, what do we get? Right. Okay. So we get this tree-like structure. Let's actually see the whole thing. So I'm just going to print out the JSON, stringify, tree, right? And see the whole tree. Right. Okay. And then let's actually save that to another JSON file, like tree.json. Oops. Tree.json. Okay. Hold on. Sorry. Sorry. Oh, sorry. Okay. Tree.json. Delete that. Let's kind of unpack what it looks like. And let's use a JSON viewer. Online. Okay. So as you can see, we have a tree, right? This is kind of small. Okay, as you can see, we have a tree, right? It's an enum because an execute message can be of multiple types of things. So under enum, we have multiple different types of variants. The first one is they're all structs, right? So the first one is a receive one, and this is like a receive message, and it's a type of struct, right? And, each struct has a definition and further members. We can go to the other ones. This one is another struct, and it is execute swap operations. So what can we see from this schema? All right, what can we see from this tree structure? The first thing is we know that for CosmWasm, each variant is encoded as a struct, right? So all of these are structs, right? Right. So all of the variants types are structs. So if we go back to Terra swap and we go to the router and we go to the, if you go to examples, let's see what does the execute message go? I think it's in packages, source, and router. This is where it's defined. Okay. So the receive is a CW20 receive message, right? Which is, sender amount message. Execute swap operations, execute swap operation, and asset minimum receive, right? So all of this is encoded in the JSON schema, and this corresponds to this tree structure that we have parsed from the schema. So by generating the schema, we have a definition of what JSON messages it accepts, but what parse CosmWasm schema does is take that schema and then give you more information about the Rust Rust data structures used to generate that schema. So as you can see, this tree structure represents Rust Rust types. For example, enum, struct, right? String, uint 182. These are all from the Rust values, right? And this description is just the comment that is tied to the Rust definition, right? So how can we walk this tree structure and just kind of go through each variant and talk and maybe just print out each variant's name and what are each of the arguments? So this would be a precursor to the documentation generator. So, all right. So now we understand the tree structure a little bit. And if we don't, we can go back and, kind of look at this for reference. Now that we understand the tree structure, we can go in and kind of walk the tree by going into each of the variants and kind of printing out the variant name and the variants like members and arguments. So each variant has, so these variants, so receive is one variant, execute swap operations is one variant, execute swap operation is one variant, assert minimum receive, that's also a variant, right? So each of these variants have members. These are structs. These are members of structs. What I'm going to do is just walk through the tree of each variant and print out each of the members. Very simple, and maybe even the member's name and the member's type, okay? So, okay, let's try that. So we go into, so we start from the tree, right? So let's see, I can use now, I know that the schema is going to be a parse schema, right? So these are types that are included by included in parse cosmosm schema that allow you to kind of get more information while you're traversing the tree. So let's see what else. And what we're going to output is a it's for any for now, but let's define what an execute message node is, right? So actually, we have an execute message node from parse cosmosm schema, right? So now we have the execute message node. We know that after we parse it, we're going to get an execute message node. So we can define this tree as an execute message node. Okay. Let's see. As execute message node. Okay. Now we can just walk the tree. So we just go tree.value.variance, and each of the variant. So what is the type of the variant? It's going to be an array of the Rust struct node, right? So I'm going to go .for each. So for each variant, which is a Rust struct node, I'm going to do something, right? So what am I going to do? Variant is a Rust struct node, and each struct has a value. So the first thing I'm going to do is figure out the name of each variant, right? The name of each variant. How Cosmosm does this is so each of the variants looks like this, like variant 1, and then blah, blah, blah. Variant 2, blah, blah, blah. So as you can see, we have a JSON object, but each of the variants is just a single, is an object with a single key. The single key being the variant's name, right? So what we're going to do is we know that this for each of the members, we know that there's only going to be one member. So we need to get the first member of this value, right? So, okay. So for each of the variants, right, we know that each entry is, let's see, variant.value.members, right? So another for each. So each member, so we have the first one is going to be the name. Right, let's try that. Let's just, as we're walking the tree, let's kind of print that out, console.log, so we know that we're on the right track. Let's try this. Okay. Oops. Let's just print that out. Okay. As we can see, we know that the first one is the function name. As you can see, we can get a struct. So each of the names, we have receive, execute swap operations, execute swap operation, and assert minimum receive, right? So now we have the function name and function body. What we want to do now is go through each of the members of the function body. So let's just print out the name, and then for each of the ones in the function body, we know it's a struct, right? So we go to object dot. So for the struct, we know that there is members of the struct, and for each member of the struct, right, we have like amount, message, sender. What I want to do is just print out the name of each member. So I'm just going to do this again. So object.entries dot members. So for each, right, now we have an argument name instead of arg value or arg body. So there's a function, and for each of the arguments, I want to let's print out the arg name. So arg name, right? Let's print out the arg name for now, and arg body we will toss for now. Okay, so now we can see that we have each of the arguments names. Now, how do we figure out the types, right? So let's see what happens when I print out the types of the arg body, right? So let's bring back the arg body, and now let's see what types we have, right? For the arg body, what happens when we try to convert that to a string? Oh, we get an object. So let's do JSON.stringify, and then do that. Okay, so let's see. For each of them, we see that we have another like parse node, right? We can. The great thing about TypeScript is that we can see like what is the type of this name. We know it's a string, and what is the type of the arg body, which is a parse node. A parse node could be anything. It could be another enum. It could be another struct. But basically, this means that it could be any type, which makes sense, right? But we have a way to represent that in Rust, and the parse cosmosm schema comes with a useful function called Rust repr, which gives you the Rust sort of representation of the node, of the parse node. So let's try this out. So let's try Rust repr and arg body. Right. And something is missing, but I don't know what. Matching somewhere. Is it here? Nope. Is it here? Nope. Where's... Oh. Oh, here? Matching braces. Okay. All right. One here. Log here. Okay. And then here. Okay. Sorry about that. Okay. And there we go. As you can see, we show that we have printed all of the types of variants, right, by walking through the tree and going through each variant and getting the name of it, and then printing out. And for each of the bodies, we're going to go in and kind of print out each of the members' names and the members' types, which is encoded in the arg body. And the arg body is actually it's a parse node, so you can have more information if you're not just satisfied with the uint 128. For example, I can go into and create my own Rust repr, right? Like if I don't like this Rust repr, let's do another one where I can provide more information. For example, there's a lot of aliases here, right? Like we know that uint is an alias for string because it's actually a reference to a string, or that message is actually a binary, or that swap operation is another struct, or and I want to go in and I want to figure out what a swap operation is, and I'm not satisfied with just this vector. I can go in and maybe create another Rust repr alt, and it's going to take in a node. Right, parse node. Let's add that parse node. Parse node. And it's going to give me a string, right? So I'm just going to add some more information. So if let's say if node.ref, this tells me if this is actually a reference. For example, uint 128, if it's actually a reference to something else. U128 is actually a reference to a string, right? So what I'm going to do is if the reference is not equal to, if it's not equal to undefined, then I want to print out like normally this would just print out the ref name, but I actually want to print out something deeper, which is, let's try return. Okay, so first I'm going to set node.ref equals undefined, and then Rust, and then return the Rust wrapper of the node, right? Or actually, I can do this. This would be better. Right. What happens if I do that, and then return? Otherwise, just return the Rust wrapper of the normal node, and oh. Right. But if I do that and Rust wrapper alt, what happens if I, use my alternative Rust wrapper? Right. And now you can see that, instead of getting the U128, I'm actually getting the actual thing behind it. Like it's actually a string, or it's actually the message, instead of being a binary, it's actually a string. Or rather than operation being a swap operation, we get this nice, is interesting representation of like, okay, this is an enum of either a struct of native swap as denom like this, or Terra swap and ask asset info. So we get more information than just swap operation. So all the information is still there. It's just this is a way of representing it. So as you can see, this way of parsing the JSON schemas and then walking the tree can open up a large variety of possibilities for creating your own contract tools. What I've shown you right here is already enough to generate documentation. You can take this information, have this tree, and then put it into and automatically generate some markdown with some templating, right? So you can do some additional processing, but this parse cosmosm schema just helps you, parse the instantiate message, execute message, and query message, or any actually Rust object created by Cosmosm. So you can build these tools for your contracts and automatically generate things. Yeah. So what's next, right? Like now that you've built this simple thing that can walk a tree, like I said, this is enough information to, automatically generate documentation. Like I have all the information I need to generate the documentation. I can also, let's say, let's add the description, right? Like I can go into the arg body, and maybe if arg body does have a description, I can add value.description. If there is a description, then it will be printed, right? Let's see if that works. So yeah, so this is obviously not pretty because I'm just printing a potential markdown thing right on the console. But as you can see, all the information is there. You can use it as you wish for, however you think of it. So future things in the future projects you can build from this, other than like the tools that I've shown. I'm thinking things like, auto-generate a mobile app, auto-generate contract testing kits. All of those can be done from this tool. So this kind of gives you the ability to build your own contract tools, and I'm really excited to kind of see what's in store. So the contract tools that I've mentioned in the keynote are still being finalized. We'll be shipping them alongside Columbus 5 because they will those are mainly targeted toward Columbus 5 contracts. Though, this tool kind of still works for Columbus 4. It's just that we haven't built those tools yet targeting Columbus 4. So anyway, the parse cosmosm Schema library is available for you to use right now to build your own tools if you can't wait. And yeah, kind of excited to see what contributions will be added. Anyway, that is it. I can be taking questions now. Okay. So I will stop sharing my screen. I can see the questions, but let's see, where are they? All right. No, actually, I can't see the questions. Most questions are about fapping, which is kind of weird. The Luna community is very strange. What is token script? Token script allows you to add logic in the wallet itself. Create agent. Let me check this out. Let's see. Pretty cool. Token script file. Okay, so this is kind of cool because this is like a structure or a way to kind of, enable, or make it easier to add like custom features to a wallet. Or, well, I haven't really understand the nuances of this, right? But from what I can see, this is a way to kind of define a spec that wallet can use and people to define their tokens on this. So I think I tried to create something similar on Terra in the beginning when gas fees were really low. I tried to create something called Terra script where you would actually just put in like in an execute message you'd put in like a list of operations, and then the Terra script would kind of just run that. It'd be a very similar to a Lisp like language implemented into a smart contract that you could call generically through Terra script, and that would allow people to kind of invoke smart contract capabilities without having to write their own smart contracts. For instance, if you wanted to create a script that made sure you got, like, you swapped at a certain price, and that it aborted if it didn't meet that price, you'd have to write a smart contract because you can't do multiple operations within the same transaction normally without a smart contract. What I mean by this is, like, let's say you're going to TerraSwap and you want to make sure that the price you execute at is the price that is given to you. That's kind of not possible with the way TerraSwap is implemented with the website, because from the time you get from the price, that might be different than when you actually execute. So, such a thing would make it possible for people to write scripts without writing and deploying their own smart contracts. However, we raise gas prices a lot, and now we can't. now that Terra scripting isn't possible, or because of the low gas limit and the high gas prices. Okay, but anyway, yeah, this is interesting, and I'm curious to see how this would be added on Terra. Maybe focusing on things outside of the chain, like creating a standard that wallet providers can easily integrate Terra assets, or different types of Terra assets other than CW20s. That'd be very interesting. How's work on Nebula going? It's going great. Free Willy. So somebody said it would be cool to get an IntelliSense type tool for VS Code. There is an IntelliSense inside VS Code because, IntelliSense was invented by Microsoft and VS Code is developed primarily by Microsoft. So, yeah. Cool. All right. I guess wrapping it up. Yeah. So let's see. Yeah. Go to try out Parse Cosmosm schema. And there is a simple guide for the structure. And if you don't understand the structure, you can go in and use the online JSON viewer to kind of analyze the tree structure yourself. And yeah, kind of excited to see what you guys will make. Yeah, anyway. I personally like this tool a lot because, you can use the schemas to automatically generate web UIs. What I'm gonna do is just kind of, instead of just inputting the JSON message, what I'm going to do is make it so that when you click submit, it opens up, station extension. It's going to be similar to the mirror tool that Carlos and Izan kind of shown you last time. So it's going to be an easy way to get a web UI quick and running. When will I be allowed back on Twitter? It's a good question to ask, though. But he said, I don't know. He said if I tweeted before Nebula was launched, I'd get fired. So my favorite upcoming Terra project, Nebula. Dun, dun. Wrap it up. Right. Right. See you guys.